Continuing on with the notes, part 2, chapter 8 notes. Electron configurations of cations and anions of representative elements. Reminder, our representative elements on our periodic table are the group 1A to 3 through 7A elements. They are the S and P block elements, not including the noble gases. Okay, so just a reminder of where our representative elements, which are gray on this periodic table. So let's start with sodium. Sodium's electron configuration is neon 3s1. How do I know? Going back here, sodium is right here. It's group, it is the 1s area. Sorry, not 1s, it's the 3s. It ends in s1, and it's the third one down. So it's going to be the noble gas before it, which is neon, followed by 3s1. So electron configuration, neon 3s1. The sodium ion, Na+, if it had lost one electron, which electron would it lose? Well, it would lose the outer electron. Or if it loses the outer electron, then it'll be just like neon. This is calcium, argon 4s2. Let me go back to the last slide. For calcium, calcium's right here. Is in an S block, S1, S2. The noble gas before it's argon. Argon 4s2 is the electron configuration, noble gas electron configuration form of calcium. So that's calcium. The charge of calcium ion, if you remember the charge of calcium ion, is positive 2. It's positive 2. It loses 2 electrons. If it loses 2 electrons, so 2 electrons it loses are these 2 in the 4s level. So are the last 2 electrons, if you drew all those arrows and stuff, it would be the 2 electrons in that 4s level. If it loses those 2 electrons, the electron configuration that's left is just argon. One more. This is aluminum. Aluminum is neon 3s2, 3p1. Going back to that last slide. Aluminum right here. Ends in 3s12. This is a 3p level, the first one 3p level, 3p1. So it'll be neon 3s2, 3p1. So that is aluminum, neon, 3s2, 3p1. What is the noble gas before it? Okay, sorry, my phone rang. I had to pause for a second. Let's see. Okay, so aluminum. Aluminum's electron configuration is neon, 3s2, 3p1. The aluminum ion is a 3+ charge ion. If you went all the way back to chapter 2 and looked at the list of ions, aluminum is a positive 3 charge. So positive 3 means it loses 3 electrons. What 3 electrons? Well, here's 1 in the p level. Here's 2 in the s level. 2 plus 1 is 3. So there are 3 electrons that are lost, the outer electrons. What's left? You have neon. The electron configuration that's left are just as the noble gas. Atoms can lose electrons, so the cation, positive if they lose electrons, it becomes positive, cation, has a noble gas outer electron configurations. So when they become positive, cations are positive, you lose electrons, they become positive. They lose electrons until it has a noble gas outer electron configuration. So they lose these outer electrons, this 3s1, this 4s2, the 3s2, 3p1. It loses these outer electrons, and it now becomes a positive cation, and it's just like the noble gas electron configuration. Okay, so that's cations. What about, it's not just positive cations, we also know there exists anions. Let's start with hydrogen. Hydrogen is 1s1. You can look it up in the periodic table, but that's hydrogen, 1s1. One of the hydrogen ions is -1. One of the charges of hydrogen is -1. Negative means it gains an electron. So its electron configuration won't be 1s1, but it will have one more electron, or 1s2. What is this 1s2? What is that the same as? That is the same as, go back to the periodic table, here, to this part of the periodic table. Notice 1s2 is same as helium, the noble gas helium. So it's the same as helium. This is fluorine. 1s2, 2s2, 2p5 is fluorine. In fact, let me go back to the periodic table for reference. Fluorine is right underneath my face right there. Fluorine is right here. This is the 2p level, 2p1, 2p3, 2p2, 2p3, 2p4, 2p5 is fluorine. If it were to gain an electron, in fact, fluorine normally is the fluoride ion. It gains an electron. If it gains electrons, it won't be 2p5, it'll be 2p6. And that is the same as a noble gas neon. Oxygen this is oxygen, 1s2, 2s2, 2p4. I'll tell you it's going to gain 2 electrons, but let me go back to the periodic table for a second. Oxygen right here ends in 2p4. Boron 2p1, carbon 2p2, nitrogen 2p3, oxygen 2p4. So if it gains 2 electrons, it'll be 2p5, 2p6. It'll be the same as neon. So oxygen, if it gains 2 electrons, it won't be 2p4, it'll be 2p6, which is the same as the one right above, which is the same as neon. Nitrogen, you look on periodic table, this is what it is, 1s2, 2s2, 2p3. Its charge is -3. It gains 3 electrons. So instead of 2p3, add 3 electrons, it'll be 2p6. That's also the same as neon. So in anions, or the negatively charged ones, remember this is all about electron configurations, cations and anions. The anions, atoms gain electrons so that the anion, the negatively charged ion, has a noble gas outer electron configuration. So it gains 1 electron like fluorine, gains 2 electrons like oxygen, gains 3 electrons like nitrogen. And when it does that, it will have outer electron configuration the same as a noble gas. Noble gases will end in P6, with the exception of helium. They'll end in some P6. So this is like a noble gas, nitrogen ion, oxide ion, fluoride ion, aluminum ion. In fact, there's a term for that. Before I get to that. Because of that, all the group 1s, they have this one outer electron. They actually want to get rid of it, which is why all your alkali metals, group 1 elements, are all +1. Group 2 elements, same kind of idea, has this 3s2, 4s2, 5s2. If you could get rid of it, it'll be like a noble gas, which is why the electron configuration, or the charge, sorry, not electron configuration, the charge of the ion of alkali earth metals are +2. Over here, they're +3. Halogens, on the other hand, end in P5, 2p5, 3p5, 4p5, 5p5. It would like to gain 1 more electron. So it'll be like 2p6, 3p6, 4p6. If it gains electrons, these halogens in general are -1. Oxygen group, over here, these in general are -2. Nitrogen group, or group 15, these in general are -3. The carbon group, now this is going to be +4, -4. This can go either way. So there's nothing specific about this. So for representative elements, group 1A elements, +1, group 2A, +2, group 3A, +3. 7A, -1, 6A, -2, group 5A, -3. So knowing that, you can use a periodic table. You can also just figure out the charge. This applies, again, just for our representative elements. This does not apply for our transition metals or our lanthanide actinides. There is no charge for noble gases because they don't react with other elements. Okay, so electron configuration of sodium ion, same as neon. Aluminum, same as neon. Fluoride ion, same as neon. Oxide, same as neon. Nitrogen, same as neon. Hey, they all have the same electron configuration. Something's 2p6, 2p6, 2p6. I don't want to say the whole thing. So they all end in something p6, which in this case are all the same as neon. There's a term for that if they have the same electron configuration at the end. The term is called isoelectronic. The sodium ion, aluminum ion, fluoride oxide, nitride ion are all isoelectronic with neon. They have the same electronic configuration. The prefix iso means same. Just think like isosceles, same sides. Okay, iso just means same. If you ever see that prefix. Okay, so what neutral element is isoelectronic with the hydride ion, H-? First of all, H- means it gains an electron. So hydrogen is normally 1s1, but gains electron, it'll be 1s2. What element, neutral atom, is this? 1s2. You need a periodic table for this. Look it up and you'll see that is the same electron configuration as helium. So H- hydride ion is isoelectronic with helium. Okay, electron configurations, cations of transition metals. When a cation is formed from an atom of a transition metal, electrons are always removed first from the ns orbital and then from the n-1d orbital. Okay, easier for you to see example. Here's iron, normal electron configuration. Okay, this is iron's normal electron configuration. It's argon 4s2 3d6. So that's argon 4s2 3d6. Now iron ion, it comes in two forms, +2 or +3. I'm going to just start at +2. If we say that we're going to remove 2 electrons, 2 plus means we actually remove electrons, it becomes positive because we take away the negative electrons. So positive, you take away the 2 negative electrons. Which 2 electrons? We actually don't take away from the d orbital. Because the rule is it's always removed first from the s orbital and then the d orbital. So removing 2 electrons, we take away from the s orbital. So this would be 4s0, or meaning it's not there. 3d6, or just argon 3d6. But let's say you're trying to remove 3 electrons. Iron also comes as a +2 or +3 charge. If it was +3, that means we want to remove 3 electrons. 3 electrons, well, you take away 2 from s, because there's only 2. But that's only 2. You need to remove 1 more. Take 1 away from the d level. So electron configuration of iron 3+ ion, also known as a ferric ion, you don't need to know that, is argon 3d5. So this is the electron configuration of iron 3+ ion. This is regular manganese. If we're talking about manganese +2, what would the electron configuration of manganese +2 be? Well, it'll be this. We remove the electrons from the s level. The 2 electrons in the s level. So it'll be argon 3d5. If it was manganese +4 ion, oops, okay, well, I don't have that written, but if it was manganese +4 ion, we'll remove 2 of here and then 2 more from d. It would be argon 3d3. I thought I had it written, but apparently not. Okay, so we'll just pause this for here.